Hello and welcome to my video presentation. This is the video presentation about material in POV. Before I start presentation, let me introduce myself. My name is Maulydinna Cinta. I'm a student from Poltekkes Ministry of Health Jakarta 1, and today I will presentation about material in POV. The next is content about number 1, material introduction, second, material description, third, function of material, 4, manufacturing process, and last is PO use and describe. This material introduction. This material first is gypsum plaster or POP. This is material 2 is silicone, and the last material is fiberglass. And the next is material description. This is material description about gypsum plaster or POP. POP is a plaster of Paris. Plaster of Paris is a quick-setting gypsum plaster made of fine white powder or calcium sulfate hemihydrate, which harden when moistened and allowed to dry. When dry, plaster of Paris does not shrink or fracture, making it an excellent material for casting mold. It's often used in medicine to produce plaster casts to keep broken bone immobilized while they recover. This is a property of POP. Plaster of Paris portray the following property. The first, it is highly fire resistant, and next, it can easily be molded into any shape. And the next, it is easy to spread. And the next, it is easy to level. And next, it does not cause cracking or surface. And next, it gives a decorative interior finish. And the next, low thermal conductivity. And the next, flexible, efficient setting time, heavy is error, can recycle, and soft during the rectification process. This is a pic of plaster of Paris. And the next, about silicone. Silicone is an inner synthetic compound that comes in a variety of form, or oil, rubber, or resin. Typically resistant to water and oxidation, stability at both high and low temperature, and rubber-like. They are present in sealant, adhesive, lubricant, medical application, cookware, and insulation. Silicon, also called polysiloxane, any of the first class of fluid, resin, or elastomers. Silicon are two types. The first type is a straight chain silicon. Second is cyclic silicon, and the last is cross-linked silicon. This is silicon property. Property first is low thermal conductivity, and the next low chemical reactivity, and the next low toxicity, and the next thermal stability, stable at min 100 to 250 degrees Celsius, and the next ability to repel water and form water jigsaw, and the next does not stick to many substrate, and the next does not support microbiological growth, and the next resistant to oxygen, ozone, and ultraviolet light, and next electrical insulation property, and the last is high gas permeability. This is about fiberglass material. Fiberglass is a form of fiber reinforced plastic where glass fiber is the reinforced plastic. This is the reason perhaps why fiberglass is also known as glass reinforced plastic or glass fiber reinforced plastic. The glass fiber is usually flattened into a shape, randomly arranged or woven into a fabric. According to the use of the fiberglass, the glass fiber can be made of different types of glass. Fiberglass is lightweight, strong, and less brittle. The best part of fiberglass is its ability to get molded into very compact shapes. This pretty much explains why fiberglass is widely used in bathtub, boats, aircraft, roofing, and other applications. Fiberglass are two types. The first step is fiberglass tape, the second is fiberglass cord, and the last is fiberglass rope. The next is property of fiberglass. Property of fiberglass is mechanical strength. Fiberglass has a specific resistance greater than steel, so it is used to make high performance. Second is electrical characteristic. Fiberglass is a good electrical insulator even at low thickness. And the next is incombustibility. Designed fiberglass is a mineral material. It is naturally incombustible. It does not propagate or support a flame. It does not emit smoke or toxic product when exposed to heat. Dimensional stability. Fiberglass is not sensitive or variation in temperature and hygrometry. It has a low coefficient of linear expansion. And next property is compatibility with organic matrix. Fiberglass can have varying size and has the ability to combine with many synthetic resin and certain mineral matrix like cement. And the next is non-rotting. Fiberglass does not rot and remain unaffected by the action of rodent and insect. And the next property is thermal conductivity. Fiberglass has low thermal conductivity, making it highly useful in the building industry. And the last property is the electrical permeability. This property of fiberglass makes it suitable for electromagnetic windows. The next is function of material. If you already know about the description of the material, then what is function? Okay, this is function of material. Function first is gypsum plaster or POP. Plaster of Paris is a building material that is used as a protective coating on walls and ceiling. It is also used as a molding and casting again for decorative element. It is used to give an aesthetic finishing touch to the building. In the medical department, is used in orthopedic to put cast around fracture bone. And the second is silicone. Silicone are used in microfluidic cell, gasket, casing, and other applications. They require high biocompatibility. Silicone is often used to make optical fiber and in plastic surgery, whereas used to fill patient body part in the form of silicone. In addition, the gel foam is used in other medical use. And the last function of material is a fiberglass. Material with high temperature insulation provide an effective thermal barrier for industrial gasket. Since fiberglass is durable, safe, and offer high thermal insulation, fiberglass is one of the widely favored material in industrial gasket. They not only provide a better insulation, but also help in protecting the machinery, conserving the energy, and ensure the safety of professional workplace. The next slide about manufacturing process. This is manufacturing process of gypsum plaster. The raw material of gypsum is a natural gypsum, or and production process of gypsum powder is normally divided into 5 stages. 5 stages is crushing, screening, grinding, calcination, storage, and transportation. Crushing. Crushing the mined gypsum or raw material enter the crusher. The braiding feeder and the crusher break the large size gypsum or into small particles smaller than 30 millimeter and then waits for further screening treatment. Screening. Screening uses a vibrating screen to separate incomplete large particles and impurities. This might increase gypsum. Gypsum with suitable available size can be spared by controlling the diameter of sieve hole, which can be used as cement additive for cell or go straight to the next step. The next is grinding. The screened gypsum are fed into the grinding mill uniformly and continuously by vibratory feeders for grinding. The ground gypsum powder is blown out by the airflow belch by the mill blower and gathered by the spirator machine on the mill. The finished qualified powder is collected by hydrosilane and discharged through the powder arrow tube is known as line plaster. Line plaster is sent by screw conveyor as a salt conditioner or transport to calcination. The next is calcination. Calcination mainly used the direct contact between high temperature hot flue gas of boiling furnace and gypsum raw material to complete the calcination and dehydration of gypsum powder. The structure and characteristics of the heated gypsum are also different under different heating conditions. And the last step is storage transportation. The calcined qualified gypsum powder is sent to clinker warehouse for storage or into the workshop to produce gypsum board cement and other gypsum products. The next is manufacturing process by silicon. The silicon manufacturing process sounds simple. Take silicon, metal chloride, and dash of catalyst. Add water, add pops an infinity assortment of silicon feed, elastron, gold, and rest shell. The hard part is obtaining good quality elemental silicon. The next intricate part is synthesizing and distilling or separating out the silane intermediate from which silicon molecules are built. That means that a mixture of different reaction product has to be purified to the highest degree to allow their further use for all the different high quality products. But the real chemistry of silicon manufacturing lies in the hydrolysis and polymerization, where the silicon building blocks are produced and assembled into a finished product. This is a picture of silicon manufacturing process. And the next slide is a manufacturing process of fiberglass. To create fiberglass, different minerals or silica, sand, limestone, kaolin clay, dolomite, etc. are melted in a furnace until they reach the melting point. Then, the melted glass is extruded through tiny bushing. This takes the form of very small orifices, typically no more than 25 micrometers in diameter. These extrusions are called filaments. These filaments are then sized or coated in chemical finish and bundled into roofing. How many filaments are in a roofing and how thick the individual filaments are determine the weight of the glass fiber, which is typically expressed in yield or yards per pound or text or gram per kilometer. An alternate form of glass fiber that is used in fiberglass manufacturing comes in the form of a continuous strand mat. Continuous strand mat is created by dispensing molten glass strand directly onto a moving pad. As the glass cools and hardens, a binding element is added to keep the product in place. It is then cut and rolled into a long continuous mat. This is a picture of manufacturing process fiberglass. And the next slide is POUs and describe. This is a gypsum plaster or POP. It is used in PO as a mold and cast. It is also used to help broken bone and cast into a supportive coating known as an orthopedic cast. Gypsum plaster or POP has two functions in orthotic and protective field. POP bandage is used to generate a negative cast of body part. POP powder is then blended with water to make a liquid plaster poured into the negative cast to create a positive mold resembling the patient limb. POP bandage consists of calcium sulfate hemihydrate generally on cotton bandage. Addition of water allows the POP to conform to the limb before the completion of crystallization process and plaster setting. In the case of big mold, cast filler in form of sand might be mixed into the plaster to lower the positive cast weight. This is picture of gypsum plaster or POP in PO field. And the next slide about silicone in PO use. Silicone is the large group of commercial silicone polymer used in medicine, including prosthetic. Silicone cushioning and elasticity provide excellent wearing comfort regardless or whether they are used in a socket for prosthesis or an orthosis. Silicone are used to create soft and flexible material that can be shaped over the patient's residual limb for protection against contact with a prosthetic device. Silicone liner reduce swelling, avoid skin abrasion, and lessen the pain that imputes often experience. Compared to other carbon-based materials, silicone are known to be more durable and provoke less skin irritation. The wide range of medical-grade silicone with different degree of stiffness possesses a variety of options to make applications such as first end bearing or cushioning pads. The next is cosmetic finger and partial hand prosthetic. The next face mask for scar compression treatment. The next cosmetic and functional partial fit. The next cosmetic glove for upper limb prosthesis. The next external memory prosthesis. The next maxillofacial prosthesis. The next is foot orthotics, and the last is socket liner. The next material about fiberglass bandage in POUs. Fiberglass bandage include knit glass fiber impregnated with polyurethane or pure resin, similar to POP. Fiberglass bandage needs to be immersed in water to be active. This bandage can be used for light supporting limb casting. However, they cannot make the same formability as POP bandage do. This is first about fiberglass bandage. And the next is fiberglass is a new innovative material in prosthetic foot design that offer increased flexibility and durability. In fact, you can expect close to zero depth support from fiberglass to fiberglass fit. Fiberglass really shine if you squat heavy weight in the gym, in part due to its so large flex window. Carbon fiber, on the other hand, has a smaller flex window, meaning your carbon foot will not show sign of stress before failing. Fiberglass provide additional rotational torsion that reduces the impact on your knees, back, and hip. This is why extreme prosthetics users who want to make a switch from carbon graphite will find fiberglass fit as their material of choice. This is presentation for me. Thank you for your attention. Do you have any question for me before we go? If you any question, please ask me in commentar. Thank you.